It is always best to start this process immediately after the aircraft lands. If that is not possible, run the engine in question for at least 5 minutes. Determine if you're dealing with a will not test or a fault issue. For a will not test issue, you are looking for an open or out of limits high resistance. For a fault issue, you are looking for a short to ground or out of limits low resistance. Pull and collar the following breakers on the P6-2 panel: A21 Fire Protection MA WRN and CONT, A22 Fire Protection ENG2, A23 Fire Protection APU, and A24 Fire Protection ENG1. It's important to do the next steps you're about to see as quickly as possible. The plane just landed or just finished the auto run, so the engine is nice and heat soaked. This will give you the best opportunity for success. I know. We're doing this in a hangar on a plane that obviously didn't just land or come back from an idle run. So use your imagination and pay attention. You might learn something. Open up the fan cowls and the core cowls of the engine that has the fire detection issue. Remove the applicable engine firewall connector for the loop you're working on. For loop A, remove connector DP1522. For loop B, remove connector DP1620. With a fluke or a Simpson meter, measure the resistance of the entire loop that the fault or intermittent fault exists on. For a loop A fault, connect the meter to pin 1 of connector DP1552. For a loop B fault, connect the meter to pin 3 of connector DP1620. Locate a suitable ground near the connector and connect the negative lead to it. The resistance should read between 797 and 901 ohms. If the resistance is out of limits, go to the core section and remove connector DP1501 for loop A or DP1601 for loop B. Your resistance should now read between 2.244 k ohms and 2.480 k ohms on your meter. If that measurement is within limits, the problem is with the engine core loops. Grab a quick snack and we will come back to that shortly. However, if it's out of limits, grab a mechanic to help you and stay tuned because we're about to show you how to find your problem. The detectors come as an assembly of A and B loops. You can identify the loop in the assembly by observing the markings on the assembly support tube in front of the responder housing. Have the other mechanic tap on each of the responder housings of the upper and lower fan loops that are in the faulty loop. Wiggle the terminal connections at the responder housing. Shake down the harness from connector DP1552 or connector DP1620 to each of the detectors for the faulty loop. While your helper is doing that, keep a close eye on your meter. When the faulty detector, connection, or harness is found, you will see a large fluctuation in measured resistance on your meter. At this point, if your issue is in the fan section, then you have found your problem. Now it's time for the engine core fault isolation. So put away your snack, grab a work partner, because here we go. Connect the meter to the J side of the connector for the loop you're working on. Locate a suitable ground near the connector and connect the negative lead to it. For loop A fault, connect the meter to pin 1 of connector DJ2501. For loop B fault, connect the meter to pin 1 of connector DJ2601. The measured resistance should read between 1.289 k ohms and 1.425 k ohms. Even if the resistance is within limits, continue troubleshooting. Keeping a close eye on the meter reading, have your work partner start tapping on each of the responder housings of the upper and lower engine core loops that are in the faulty loop. Wiggle the terminal connections at the responder housing. Shake down the harness from the DJ2501 or DJ2601 connector to each of the detectors for the faulty loop. While your helper is doing that, keep a close eye on your meter. When the faulty detector, connection, or harness is found, you will see a large fluctuation in measured resistance on your meter. If you saw the meter fluctuate during the last procedure, then you have found the problem. Well done. If the meter was steady the whole time, then we have some more work to do. Let's see if we can't get this pesky fault to show itself. The next procedure will walk you through checking the health of the harnesses that connect the detectors together on the engine. The fan section harness is universal throughout the fleet. However, there are 3 different types of engine core harnesses used at Southwest Airlines. Connect the meter to pins 1 and 2 of the engine core connector for the loop you are working on. While observing the meter, have your work partner shake down the engine core harness between the connector and the responder housings of the fire loop assemblies for the affected loop. The meter should read less than 3 ohms. If there is a large fluctuation in the measured resistance or the measured resistance is out of limits, the harness requires replacement. While shaking down the harness, pay close attention to its condition. Look for any signs of chafing or breaks in the wire. If the new style CFM or Megget harnesses are installed, make sure the insulators are installed and in serviceable condition at the clamp locations. If there was no fluctuation in measured resistance and the value is below 3 ohms, reinstall connectors DP1501 and DP1601. Move back to the fan section and install the meter leads into the correct pin combination for the affected loop. While observing the meter, have your work partner shake down the fan section harnesses between the connector and the responder housings of the fire loop assemblies for the affected loop. While shaking down the harness, check for damaged wire, chafing, or damaged connections. The meter should read less than 3 ohms. If there is a large fluctuation in measured resistance, or the measured resistance is out of limits, the harness requires replacement. Hopefully you found your problem by now, but if you haven't, I would offer this advice. If your first reading at the firewall connector is within limits, 797 to 901 ohms, while the engine is still hot, keep the meter connected. Have your work partner tap on the responder housing and responder connections in the fan section and the engine core of the affected loop. There's a good chance the bad loop will show itself. I hope this video helps you all out, and we appreciate all your hard work and dedication. Happy hunting.